Thank you. I'm Vinicius Pacheco. I'm from Brazil. I have a funny accent. I'm based in Argentina. And I'm senior software engineer at Eventbrite. And it's a very cool company. And without the support from this company, it's impossible to be here. I'm coming from Mendoza. Was 20 hours in flight. So Mendoza, Argentina. And please, applause for this company. They are amazing. Thank you. If you don't know me, every time I gave normally Star Wars talk. And today, it's not different. So after this moment, I can't hear you. So, okay, now it's better. I released a book earlier this year in January. And the content of this talk, the subject of this talk, make part of my book. There's the link and my Twitter too, if you want to buy it. The ebook's very cheap. I think it's just £9, something like this. And let's start. Our agenda. What is CQRS? When can we apply this? Understanding CQRS, applying, there is a live code, and the common mistakes. When you see a Yoda on the screen, there is a live code, okay? It's the rule. So, what is CQRS? Someone here have been working with CQRS? Just to know, well, a couple of people. Someone know what is CQRS or listen something about this pattern? Okay, great. So, there's no doubt. Command, query, responsibility, segregation. It's what means CQRS. It was a pattern documented by Greg Young, and he taught this about the pattern in 2010. Basically, where you have just one object responsible to change things in the server and to retrieve data in the server, you will split this in two different segments. That one will be responsible to write and another one responsible to read. So, when can we use CQRS? There is a Chewbacca. I love Chewbacca. He's fun. So, the normal architecture. Thinking the normal application architecture. No. It's not this architecture. This one. There is an UI or API, a domain, a repository, a model that's responsible to connect with the DB and to write and to read stuff, and could have a controller or something like this. It is our Bootstrap application. So it's an instance of my Bootstrap application, and it's connected with my storage. And when I deliver a business to the internet, there is a word that's very dangerous to my business. This word is success. And why? With success, there are more customers, more clients, more people connected with me, and now I have a problem. And why? My application has a limit, and I will rent a new machine. Okay, it's great. And this process is repeated over and over and over again, and I have a new instance and another instance, and now I could figure out that my scalability is not more linear. My second instance could have a linear scalability, like, okay, I have, I don't know, 10,000 requests per second, and now I have 20,000 requests per second. But there is a moment that my scalability is not the same. I cannot scale 50% or it's just 10% for each new instance. And why? Because maybe your issue is not in your application, but in the storage. And there's another instance that doesn't scale very well, and now it's over. my storage starts to create too much latency, or he's very responsible to do things that is not prepared to do, and my business out. It's a sadly day. So there is a first option to try to scale to solve my problem. And do you know what is this option? Someone knows? Someone? No? No? Master-slave. It is my first option. There's a slave, you know, like a slave from Jabba the Hutt. And yeah, she's a slave, yeah, okay. Master-slave. And there is my application. Now I have the master-slave, and I'm just replicating the data from my master, and my master is going to receive all the writing process, and I'm going to replicate this to my slave that will be responsible to retrieve the data. But in fact, I'm not optimizing the data. I'm not optimizing the queries. I'm just replicating the data. And it's very hard to measure how many slaves I have. And when my problem is in the writing process, my problem is to write, it's very difficult to figure out how I could improve stuff on master. And it's not the solution for this specific kind of issue. Okay, it's a good approach, but not a solution. And there is another stuff, eventual consistency. If you don't have the good conscience that, okay, there's in my mind, I would like to use eventual consistency. Okay, it's okay. Eventual consistency is good sometimes. But if you don't have this in your mind that accidentally you are using eventual consistency, it's an issue for you. Okay. And there is a second option. Do you know what is this option? Someone knows? Someone knows? Mind to remember, like control. No, it's close, but it's not this, not command. Someone? No? Okay. It's cache. Because it's memory, you know, like my trick. So, yeah, bro, erase your mind. Yeah, like saying, yeah, Obi-Wan Kenobi is great. So, it's a good strategy. Now, I'm put a cache, and it will remove some heavy processes over my database. And it's okay. But I'm not optimizing the queries yet. And I'm optimizing a segment that normally is not so expensive than the writing process. So read normally, usually, is easy than write things on DDB. And I'm trying to optimizing my issue, that's write and read, just optimizing the read process. Okay, and there is another stuff that's very hard. If you are old in IT, you know that there are two things that is very difficult. The first one is named classes, and the second one is invalid cache. So, and now I have data synchronization. The first one is invalid cache? Okay. So, it was a pleasure, but I can't hear you. Sorry, it's the ear. When CQRS is util, when my storage is a bottleneck, definitely you could use this pattern as a solution. When I have complex queries to my ORM, and they could optimize these queries. And when they have a big number of users updating a small data set, and the data could be outdated. In fact, if you think on the Facebook feed or in the Instagram, every time you are consuming data that is outdated. And why? Because when you are looking, someone updates the feed. So it's eventual consistency every time. It's not, okay, I have my consistency, it's very well, it's totally right. No, it's not true. It's not true. In fact, for business that a huge number of users are updating a small data set or a small piece of code like a feed, you have eventual consistency every time. And for this, CQRS is a good pattern. So, understanding CQRS. Teach me, said Ray. I don't like the last two movies, but yeah, I prefer, Star Wars have just 6 movies. And the cartoons, I like the cartoons, Clone Wars. Come back. Yeah. Oh, look, Jar Jar Binks will appear here. Yeah, you will see. Not boo yet. There is a good motivation. Query stack in the command stack. Basically, the CQRS is divided in 2 big pieces. The query stack that's responsible to retrieve data, and the command stack that's responsible to administrate my writing processes. Okay. The query stack is simpler than the command stack. It's synchronous normally, and presumes flat queries. Do you know what's a flat query? Someone don't know what's a flat query? Okay. A query could have joins. It's a simple explanation about flat queries, okay? It's a poor explanation about flat queries. A flat query is every query that I'm going to optimize the data to reduce the number of joins that I'm going to do in my database. So if I know which kind of data I'm going to retrieve, I will prepare this data to return with just 1 index or 2 index, but not doing joins and going to the deep level on my data. So it's basically this. And the command stack is potentially asynchronous, has a behavior-centric. So each command looks like a use case and has an imperative fashion. So it's not more just a post for my endpoint user. No, the endpoint is an imperative command like create user or update the username or something like this. It's a command. And the command handlers just return success or failure. Like, I accept your request, but I don't know what happened. I don't know what will be the result. And the command updates the own entity that make parts of the command stack and going to dispatch events that there is an event component that will be responsible to update or to normalize the order DB or the order storage that the responsible is the query stack. Synchronization. There are 4 ways to synchronize data using CQRS that's like by the book. So the first one is the automatic update. The automatic update is like I receive the data from my put process, my post or put, my command, and now I'm going to send an event that is totally synchronous using RPC or binary communication or REST, and it doesn't matter, but the component responsible to normalize the DBs will do this stuff instantaneously. So, there is the update possible. Update possible is the most common synchronization in CQRS. So, the command going to dispatch an event, and the storage this information on a bus or on a broker or on a queue, and the component will be responsible to consume this event and normalize the DB on the query stack. But there is all the time of the world to do this. The third option is the controllers update. So I'm going to update, to normalize my DBs every 2 minutes. Is an example. There is a cron responsible to normalize the data. And the other option is the update on demand. So when I receive a GET to my query stack, the query stack is going to check, hey, I'm outdated. If I'm outdated, I'm going to say, hey, please come on, give me the data. and going to be created a new event that the CQRS stack is going to consume and write on DB. So, queuing. It's a diagram that there are many diagrams about CQRS, and I like specifically this one. And why? Because it's like if you follow this diagram, you could use all these synchronization styles, okay? And it's very flexible diagram. So there is a client UA API internet that's going to talk with my public facing if we are thinking services. And my public facing going to deliver a command. The command will include the information, and my domain layer gets the information, and the domain knows what is necessary to do. And the command will update my normalized DB, that's my source of truth. Normally, this one here is SQL DB, and going to dispatch an event. This event will be queued, and a event component will start to consume this queue and write this stuff in the unnormalized DB with time, or directly, but normally with time, usually with time. And this unnormalized DB is very common to see NoSQLs here, or document DBs. It's common. It's not mandatory, okay? And but the main point is this command will create the flat query, so optimize the stuff here to be found easily by this request. So let's figure out something here. Applying CQRS, how an Yoda. If there is a Yoda, there is a live code. So all the code is on this link. Okay, there is a small project, Dockerized project, using CQRS. It's totally didactic. It's just for the EuroPython. You could download this and do some experiments. I'm using the Nameco framework in this example. Docker, Mongo, Postgres, and RabbitMQ. So it's the same diagram, but now I changed the names of the components to be clear what's going to happen in our service. It is a user service, okay? So let's see how long time I have. I have time. So my create user, it's the imperative command. And there is a convention that every event, we will name it in the past. So user created. If I dispatch another event, will be in the past too. So let's see. No, let's come back. Now, the code. Let's figure out what we have here. There is my Docker compose. The CQRS stack, the DB is a MongoDB here. It's a MongoDB. The command stack is Postgres. There is my command stack here, okay, my Postgres. And I'm using as queue a RabbitMQ, okay, and my user service. The user service entities are the user model, okay, and my permissions model. I could have two permissions, admin or user. So I'm going to do a post, and I will write a new user and the permission that the users, this user have, and is it. There is the other entities or structures that are going to use to my, in my MongoDB. Okay, the service. I could write this in different modules like domain module, repository module, this kind of things, but I wrote all the code in the same file to be easy to navigate. Okay, there is the framework and some configurations, but it's my API. Okay, my API. There is a reference to my query stack, and it is my post. My post is the first layer on my command stack. This post going to receive the data from my request, validate if the payload is a valid payload, and prepared a cluster of RPC communication to do a sync RPC, and to put this on my queue, and And I create a location, and I go into dispatch an 202 event with the location where will be the data, when the data obviously going to be consumed by my query stack. Okay, on my API, there are an API to get all users paginated, and the user by ID, and the user by permission. So I want to get all the users that has the same permission. It could be a join on my DB because I have two different entities, but won't be. Will be a flat query. So there is my command stack, and inside my command stack I put my user domain. It could be another module, domain, but now it's there. So my command stack, I have it's just to use the framework. It's a dispatcher, an instance of event dispatcher, and an instance of the DB. Now I create my entity, I commit this, and I dispatch an event that's user created with the data. And I will dispatch another event to create the relationship between permissions and users. That is my permission user related. Okay? Could be a broker. So I could have two different event components listing the same this event using a broker. But I'm dispatching two events just to be easy to look what happened. And there is my event component. So look in this, where we are stopped. The user, queue, the domain, your dispatch user created, and now I'm going to show the component. The component going to listen the user created event. And get this stuff, create the data, and normalize the data on my MongoDB. The other stuff is I'm going to get my permissions user related, and create a structure, look if my permission was created or not. If not, I'm going to create one. If it was created, I will just append this user structure on the permission that's existing on my DB. So, on this event, I'm optimizing the data. And why? Because I removed the possibility to use joins, because all my data was prepared to be retrieved with just one ID. That is the admin ID, or the user, the permission ID, sorry. And now the query stack. The query stack, there are just endpoints using RPC to communicate with my API. The first endpoint gets the information from the MongoDB. The second endpoint gets paginated information about users. And my get user permissions, by permissions, is exactly that going to find on the flat query. And if you take a look, is the same query, the same style of query that I'm using to get a user by ID. So it's very easy. It's not expensive, this search to my database. So let's see if my containers are running. All's fine. And let's start to consume, to send the data. So first, I'm going to get the info. There's nothing. No users. And now, I'm going to insert the first user. That's me, Vinicius Pacheco. It's just a simple test. And this user is an admin. OK. Sent it. He was accepted. OK. I don't know what happened. And there is a location with my data. OK. And now, if I find here, there is my user. OK? I'm going to create another two users. The other one is Vinicius Feitosa. That's me again. And it's an admin. Was accepted. And now, I'm going to create the Vinicius Pacheco, but now as a user. I don't remember if Vinicius Pacheco was accepted. Let's see. This was too fast to me. No, it's Feitosa. Was not the last Pacheco. Now, so if I find here, there are 3 users. Admin, admin, and user. But I have the user description, but not the description user. So now I'm going to find just my users that the permission is admin. And there is my query using CQRS. So my data was moved to my query stack. And now there is the admin permission with the description and all the users that are an admin. In the query, there is no joins. It's a flat query. So now I'm going to find my user, and there is the other user that's just a user. The usability is the same than a normal application. So to my user, it's not so different. And if you look at this, OK, it's the same that I have been using in my life. But the main point is, now, let's come back to this. If my normalized DB fell down, it's broken for some motivation or locked, I don't stop at my query stack. And my users will consume the data. And if my query stack is over, I could write in stuff. Obviously, Vinicius, it's just a user service. It's not so critical. But thinking due payment. You could receive a payment, but not retrieving the report about the payment. But you are selling stuff yet. It's important, I think so. And once, in another job that I have, the disk of the normalized DB broke. And we maintained the application running. It was like a monkey test. We maintained the application running because all the writing process kept stopped on the queue and was stored in the queue. When we restarted the DB using the slave, we could reproduce all the stuff on the DB. And we don't lost the data. But it was just a moment that the unnormalized DB doesn't receive the data. And it is amazing. It's very scalable and maintainable, and obviously make your application stable. So, and it's simple. Simple. It's not so hard. So, common mistakes. And for common mistakes, there is a Jar Jar Binks. It's a common mistake. Jar Jar Binks is a common mistake. Okay, yeah, George Lucas, thank you. So, but not Rust, then the guy in the new movie. I don't know why Benicio del Toro did the last Star Wars was terrible. Was Rust character, Rust than Jar Jar Binks. I don't know. Jar Jar Binks eat some insects. I don't know, some bugs. So, CQRS and event sourcing must be applied together. It's not true. It's a common mistake. There is an example that I'm just using CQRS. They have different proposals and they work very well together, like Han Solo and Chewbacca. But they have different proposals. One is to improve performance and scalability and stability. And another one is to create a streaming history about your data. So event sourcing, using event sourcing, you could reproduce the data in a specific moment of the time and to know what happened. So CQRS going to improve your stability and performance and make a better application for you. So, CQRS requires eventual consistency. Eventual consistency is the most common usage. It's the most common scenario in CQRS. But if you try to use the first option of synchronization that I shown, it's not eventual consistent. It's not totally eventual consistent. Try to be fast. But it's not mandatory, eventual consistency, in CQRS. CQRS depends on queues and message brokers. It's a good practice, but not mandatory. So you could use CQRS trying to trigger at some events or using logs from your data, like MySQL logs or something like this. There are many usages that you could use. I like to use queues and message brokers because I think that's easy to create an intervention or to monitor it. CQRS is easy. It's not easy. And why? There are more things to monitor. There are 2 DBs to take care. There are many stuff in your stack that isn't in a normal application, the normal architecture that we looked at earlier. So CQRS is not easy to implement, but not so complex as we think. You know, if good tools, you could have a good implementation. CQRS is architecture. No, it's not architecture. It's a pattern inside your architecture. So it's a good pattern that is cross-platform. It's not for Java or just for Python or for Go or for, doesn't matter. It's for everyone could apply CQRS as a pattern. It's not an architecture. And my English teacher told me, she's from Dublin, and told me that's very funny. I don't know. CQRS is best thing since the sliced bread. And she told me, oh, it's so funny. The sliced bread. So Sarah, thank you by the English class. I'm bad. And again, there's my book. If you would like to learn something more than CQRS or other patterns, there is an interesting pattern that I documented that the caching first is interesting, and another pattern is internal patterns for service and the communication patterns. It's very steeper than a lunch here and the dinner. So the ebook, obviously, and there's a link. Please give milk for my kids. I don't have kids, but yeah, my cats. And may the CQRS be with you. And, okay? Thank you.
Thank you. So, any questions, please come up here.
So,
No?
there.
Okay, so I have a question.
Okay.
Yeah.
Yeah, oh, there is a question. Oh, okay.
okay.
Yeah.
So I have a question. I came in slightly late, so I probably missed it, which is my bad, I'm sorry, and maybe missed the very introduction. And also, it's quite new to me. So I'd like to clarify my understanding. So what I gleaned from is that you use two databases. You have your normalized database, which is your canonicalized data store, and you have an unnormalized database, which is specifically optimized for the queries that you need, so that the straight queries can go to the denormalized database, and that provides the primary advantage of the pattern you're advocating. Did I get that right?
If I understand your question, yes. My idea is create a curve stack, the curve stack responsible just to retrieve the data. So should be the most optimized as possible. And you could apply cache and all the stuff over this stack. I don't apply to make the example because I would like to make it simple to see. But you could take care of this query stack, this query DB, like all the others DB, but other source of true DB. But the main idea is optimize this segment of your stack as possible.
And does this mean that where you have schema changes, you have to apply migrations to, or where you have to apply migrations to both databases? Where you have new queries, you have to generate a whole new set of data into your second database?
Oh, sure. My entities are different on both DBs. Right. So my entities, my migrations, it's another stuff. Okay? I'm doing this. Some people just try to reflect the same entities, but it's like presume flat queries. It's not mandatory to use flat queries. If you try to use flat queries, I see that you should, maybe you should create new entities specifically for the query stack.
Yeah, it was a really interesting talk, and I enjoyed it and learned from it. Thank you.
You're welcome.
Okay, I'm basically going for the same. So when you are going into the right part that you need to scale, and you said in the start of the talk, how you actually going to scale. So you're going to have different write instances, different write databases with different schemas, or how is the approach for that?
For which?
For the command part. So
to the command part, the main idea is command normally is thinking, I will use a practical example. MongoDB in the version 2. To put something in MongoDB in the version 2, block the read. Okay, in the version 2, not more in the version 3. And, but maybe for your business, it's interesting to use the Mongo engine. So using CQRS, you could totally divide this. The simple separation of stacks improve performance because now the writing process won't lock the query process. The scalability using master slaves and different instances and this kind of things is practically the same. The main goal of the pattern is segregate the responsibilities to make this more resilient and improve performance to don't make that one operation lock the other. Okay. It's the main idea. No, but the instance control of the bees and this kind of stuff is the same approach.
So the write improvement, so how you're actually going to scale the write part, that's what I mean. So you're going to queue and you want to deal with a queue that if it's delayed, the queue will be taking, or?
You could apply chargings as an example that will be very optimized and is not so optimized in some engines for query stack. because what happened with some engines using charging 4dB, you have an instance that's responsible to administrate all the other DBs. That comes, is going to write because that's more idle, will get the request and write on the DB. But to find maybe is not so interesting because you're going to receive the request by the time charging and that should find in where is the data, while this data was not propagated for all the chargings. And in using CQRS, it's not an issue. And why? Because you are not interested to use this this collected data from the charging, because the charging is just the source of truth. It's improved performance on the writing segment. And your data is streamed on a Kafka or RabbitMQ or ActiveMQ, doesn't matter, and it will write in the query stack that's responsible to retrieve the data. So that could have another approach to scalability different than charging. Mm-hmm. And it's just an example about, oh, you could use charging, you could use master-slave decide, you could use all the stuff that is fast to read, but is slowly to get data. And this kind of approach is not more an issue if your business requires too much retrieve, too much search.
Okay.
Okay.
Thank you.
Hi. When you were talking about the different strategies to synchronize the two stacks, you talked about the synchronized, the event-based, that it's the one that you explained, and then you talk about if I understand good, the query stack asks for an update when he knows that it's outdated. It's how he knows that it's outdated.
There are some approach to use this. It's the more harder to apply. It's the hard way to apply. And it's very, usually the people create like a semaphore in the streaming too. Like on the streaming, there is this, you put a semaphore on the Kafka and okay, I'm very outdated from this because the data streamed is, it's there or it's full and I'm going to get the information from the common stack. And there are the logs of the DB that you could consume in this and check, okay, my DB logs are very full. I moving DB logs from different segments of your server, and okay, it's full of logs, and I should consume these logs to create my to improve my query stack. There are two different approaches. One is that's more common, okay. One is looking the bus and to see if there is a signal to consume the data. And another one is looking the DB logs that you reserved a specific part. And a very common approach is using like a JVM separation. That's the hidden and the old part of DB logs. And when you consume the data, you move the hidden to the old part of the logs. And if the hidden is full, it's time to get the data again. And the logs is optimized to use to element, to bring the sufficient information to register on the query stack. Was clear or was? Yeah, well, we could talk. It's hard. We could talk and more calm, and will be interesting. More questions? Okay.
Thanks for the talk. I really enjoyed it. It seems to me that when writing to, say, the local flat database or the MongoDB, whatever it is, your data predominantly comes from the events, at least in this example. However, when you start a new application running, a new service, presumably, or in other scenarios, you need to be able to read the data from the relational database that stores the canonical representation. And it seems to me that there's some complexity there in the sense that you need to be able to write to local database using two different sources of information. You need to be able to have the logic to do the writes based on events or logic to do the writes based on the relational database. I was wondering if you find that's a problem for you or how you manage that complexity or those two different kind of pieces of logic in your implementations.
Yes, it's one of the drawbacks using CQRS. Mainly if you want to create specialized queries. If you just want to replicate and segregate the search and the find and the write process, it's okay. It's not a consequence. But if you want to create flat queries, it will be a consequence. You will have the two different, I'm going to show you something here. If you look my model, specifically for this business, I'm using a user, and there is it's my Postgres, okay, 2 tables, and there is a document for the user that's going to get the user information, just user, and I create a struct to create an embedded document here. So I have different entities, and I have different logics, and it will be a normal scenario inside CQRS if you're trying to create flat queries. The mistake that you should take care of is don't split the domain rules between the event component and the domain. So it's a normal mistake. Here, on my domain, I prepare the data to be consumed by my event component, okay? All the data. I'm dispatching 2 events. That's not a good practice, but I'm dispatching just to show the stuff. But it's very common to see something like this. Oh, I would like to create a relationship between permissions and users. And I don't want to have both entities being consumed in the same domain. So it's like consume 2 repositories in the same domain. And the people move the second part to here. And it's a real mistake because you start to split the domain. And it's a mistake. But 2 different entities, 2 different logics, one specialized to write and another one specialized to read, is exactly what CQRS means. Okay?
Thank you again. And so enjoy your lunch, I guess.
Thank you. If you have more questions, I'm able to answer you. Thank you.